you have a 10% salt solution and a 40% salt solution. How many liters of each should you mix to make 20 liters of 25% salt solution? So when you're dealing with mixture problems, you're going to deal with two solutions, and then you're going to be mixing these two solutions, and you're going to be getting a final sort of solution that has a different concentration than what you start with. You want to see how much of each should you add. Now let's define what concentration even is in the first place. So concentration is just going to be equal to the amount. In this case, it's the amount of salt you have divided by the volume of thing. All right. So for example, let's say if I say that I have 10 liters of a 30% salt solution. What does this mean? I have 10 liters of 30% salt solution. Well, all this means is that 30% of my volume is going to be salt. So essentially, 3 liters of my solution is going to be salt. That's all it means, all right? If you have 10 liters of a 30% salt solution, that means 3 liters of it is salt, and the remaining 7 liters of it is water. And the math works out when you use this formula, right? Remember, concentration is equal to the amount of salt divided by the volume. So right now we have our concentration, which is 30%. So that's the same thing as 0.3. And it's going to be equal to the amount of salt. Well, we don't know that, right? So let's just put an X there. It's going to be divided by our volume, which is 10 liters. So 0.3 times 10 gives us 3 liters, which we can solve for X right over here. Now, the point of this mixture problem right over here is to realize that the amount of salt, so the amount of salt in container A plus the amount of salt in container B is going to be equal to the total amount of salt. So the amount of salt that I add in container A or solution A, and I add that to the amount of salt I put in container B, well, that's going to be equal to the total amount of salt that I have, right? And that makes logical sense, right? This is going to be equal to the total amount of salt that I have in my final solution, right? So amount of salt in A plus the amount of salt in B gives us the total amount of salt in my final solution. Now, what I can do right over here is I can rearrange my original equation by multiplying volume on both sides. And if I multiply volume on both sides, this is going to cancel out, so now I just get this. So we get that the amount of salt that we have is equal to the concentration multiplied by the volume for that specific solution. Now, we see that we have the amount of salt in A, we have the amount of salt in B, and then we have the total amount of salt. So let me just substitute concentration multiplied by volume in each of these equations, right? Because all of them contain the amount of salt, which is right over here. So we're able to do some substitution here. Now let's see what we get. So we substitute everything in here, and we get that essentially our amount of salt in container A is just going to be the concentration in container A. I'm just going to write C1 multiplied by the volume in container A. That's going to be added to the concentration of container B, right, of the salt in container B, multiplied by the volume in container B. Then that's going to be equal to the total amount of salt, which can be expressed as the concentration of the final solution that we made multiplied by the volume of the final solution that we made. So all of this seems complicated, but it's literally just you substitute concentration multiplied by volume in all of this, and you get concentration multiplied by volume down here. So let's just put this formula to use for this problem. All right, if there's one thing I want you to take away, it's just this formula. So you have a 10% salt solution. So our concentration is originally 0.1. And the volume for this first solution, well, we don't know because we want to find out how many liters of each should I mix. So I don't know how much sort of volume I should kind of take in, right? So because this practice problem doesn't give me a volume, I'm just going to put an X here. All right, that's my unknown. And this is going to be added to the concentration in the second thing, which is 40%, so 0.4. And this is going to be multiplied by the volume of my second container. Now, once again, the problem is that I do not know that. However, what I can put right over here is I can put a minus X right over here. Because I know that I'm making 20 liters of a solution, right? I know that I'm going to end up with 20 liters of my solution. So therefore, if let's say x is equal to 4 liters, then that means that I know my second container has to put in 16 liters, right? In order to make the total 20 liters that I end up with. So if this is x right over here, if I do not know how much volume I'm putting in for the first container, that means that my second container is going to be 20 minus that unknown volume, because that's eventually going to add up to the 20 liters that I have in total, right? So that is where I get the 20 minus x from. And this is going to be equal to the concentration of the final solution, which is 25%, right? And it's going to be multiplied by the volume of the final solution, which is that's 20 liters, right? So then after that, you could just do the distributive property on this, just do some algebra. Okay, so I just multiplied everything out and I got this. Let's combine like terms now. So I see that this and this can combine. So I get negative 0.3x, right? Plus 8 is equal to 5. I subtract 8 on both sides. I get negative 0.3x is going to be equal to negative 3. Divide by negative 0.3 on both sides. And I get that x is equal to 10. Okay? And what this x equals 10 tells me is that, well, if I essentially add in 10 liters, so I'm going to add in 10 liters for my first solution. And actually, if I plug in 10 here, this is 20 minus 10, which is also 10. So, all right. All this is saying is that if I add in 10 liters of my first solution and I add in 10 liters of my second solution and I mix these solutions together, I'm going to get a final 20 liters with a concentration of 25%. That's all this is saying. In order to reach this goal right over here, I'm just going to add in 10 liters of my first solution and 10 liters of my second solution, and then I get my desired concentration. Here's another problem. 5 liters solution, 10% salt. 10 liter solution, 30% salt. You mix them together, and you want to find out the concentration of the resulting solution. So we're going to use this formula. The concentration of my first solution, which is 10%, so 0.1, multiplied by the volume. So in this case, we're given that we poured out 5 liters of this, right? We're using 5 liters of this. And then we're going to add this to concentration of my second one, which is 0.3, multiplied by a 10-liter solution. So I'm just going to multiply this by 10. And this is going to be equal to the concentration of my final solution, which I don't know, right? That's what the question is asking us. We want to find out the concentration of a final solution. So we don't know that. I put an X there. And then the final volume is going to be 15. If I put in 5 liters of my first solution and I put in 10 liters of my second solution, then my final volume is just going to be 15, because 5 plus 10 is equal to 15, right? And then all I have to do is just solve for x. So I'll just divide everything here by 15. This cancels out, and I get that. All right, so I actually get a little decimal here. I get 0.2333, and it just like keeps repeating. It's important to know that so my final concentration is going to be equal to 0.23333 repeating. However, concentration can also, it's usually expressed as a percentage, like, in the problem right over here, concentration is represented as a percentage. So all I have to do here is just multiply this by 100%, and I get, this is about 23.3 repeating on percent. So this is going to be the concentration of my final solution. Finally, let's end off with a bit longer problem. So 5 liters of a 10% acid solution, some amount of 20%, and some amount of 40%. So now we have 3 solutions this time. I want to mix all of them, leading me to a 20 liter of 30% acid solution. So the good thing about the formula for the C1V1 plus C2V2 is equal to C final V final is you can add as many mixtures as you want. So you can add a C3V3 here, you can add a C4V4, you can add as many other mixtures as you want, because all of that is going to add up to the final mixture. So it really doesn't matter how many other mixtures you add. You can always keep adding more solutions or mixtures. Anyways, so we know that I have 5 liters of a 10% acid solution, so my concentration is 10%, and then my volume is 5 liters. I'm going to add that to, well, the second solution is 20%, and my volume is, I don't know what my volume is, so I'm going to put an X there, plus third one is 40%, and then I also don't know what my volume is. But I actually have to be careful here, because I know that I want to mix all of them. so that I get 20 liters of a 30% acid solution, right? I know I want to mix all of them to get 20 liters of a 30% acid solution, right? That's what I want to do. Now I already know that I'm using 5 liters of this solution. Oh my god, that was a horrible voice crack. So effectively, these two solutions should add up to be 15 liters, right? Because I'm using 5 liters for this. And I know that I have to get 20 liters in total. So I know these two mixtures right over here have to add up to 15 liters in total, right? Because 5 plus 15 gives us 20. So if this value is x right over here, then the volume for my last mixture has to be, guess what? 15 minus x. So if this x right over here was, let's say, hypothetically, it was 5, then that means the volume for this is 15 minus 5, which is 10, right? Because all of this adds up to 20 now. So that is what you got to do. So just be careful when you're doing like this problem with like multiple mixtures. All right, you always want to check what you're given and then what's like unknown. Now this is just going to be simple algebra calculator stuff. Okay, let's see what we have here. I simplified everything down. I can see that if I subtract 6 from both sides, these two 6's just completely delete each other. So I'm essentially just going to get 0.5 plus this. So these 6's delete each other, and this becomes a 0. So I essentially get 0.5 plus 0.2x minus 0.4. Sorry guys, I accidentally forgot to do an x here, right? Because when you distribute the 0.4, you have to multiply it by this negative x also. So there's x here. Sorry guys, I might have deleted that actually. But 0.2 minus 0.4, that's going to give you negative 0.2x. And then this is going to be plus 0.5, and that's going to be equal to 0. I move the 0.2 here, divide by 0.2 on both sides. So I get x is equal to 0.5 divided by 0.2. And let me see what that is equal to. That's equal to 2.5. So that means that if I plug 2.5 back into this, so I'll plug 2.5 back in here, and I'll also plug 2.5 into this x, and 15 minus 2.5 is 12.5, so this essentially all is 12.5. So to sum it all up, I'm going to use 5 liters of my first mixture, I'm going to use 2.5 liters of my second mixture, I'm going to use 12.5 liters of my third mixture, and mixing all of them together leads me to a 20 liter solution with a concentration of 0.3.